In my other videos, I have used the absolute value and certain properties of the absolute value to either prove or define something. So because of that, I figured it would be useful to make some videos proving these qualities about absolute values. But first, let's define what the absolute value is. So for example, let's say I write absolute value of x. So what does that mean? Often the intuitive definition of absolute value of x is the distance from 0. And this kind of makes sense with the way we would compute it. A distance is always positive. So therefore, the absolute value of something is always positive, or non-negative in the case where x equals 0. And when x is negative, defined what the absolute value is, we would multiply by -1. So how do we define this rigorously? Well, we can do so as follows. The absolute value of x is equal to x under the condition that x is non-negative. And I'm going to say this as when x is greater than or equal to 0, it is equal to x. However, when x is negative, we multiply by -1. So therefore, if x is negative, the absolute value of x is equal to -x. So we can write that here. So this kind of definition takes our x and says, under certain circumstances, it will equal positive x, and under certain circumstances, it will equal -x. Now the first property I want to look into is the following. This is the idea that the absolute value of x is greater than or equal to x. And intuitively, we can think about it this way, right? Absolute value of x is the positive version of x. So if x is positive, then the absolute value is the same thing, so they're equal. And if x is negative, then the positive version will be greater than the negative version. And remember, if we're looking at a greater than or equal to, only one of them has to be satisfied, right? If it's either greater than or it's equal to, then this statement is true. Now with that in mind, we can split this into two cases. Just like we define our absolute value under two conditions, we can determine whether this is true under those conditions. So the first case will be when x is non-negative. So we can call this case 1. So in the first case, x is non-negative. So that means that the absolute value of x is equal to x. So in this case, the absolute value of x is equal to x, so therefore this statement is true. Right? This statement, that the absolute value of x is equal to x, and that this statement, absolute value of x is greater than or equal to x, these can both be true, because in this case, they are equal. So it's greater than or equal to, because it is equal. Now the second case. This is the case where x is negative. So case 2, x is less than 0. Now the first thing I want to think about is, if x is less than 0, what else can we say? Well, if we multiply both sides by -1, we can also say that -x is greater than 0. Right? And a good rule to remember is, if you multiply by -1, then you flip the inequality. But another way to think about it is, if x is a negative number and you multiply it by -1, then you get a positive number. So there we go. negative x is greater than 0. And absolute value of x is equal to negative x, right? Because we've chosen this case where x is negative. So is negative x greater than x? The answer is yes, because even though we have negative x, it's positive because we're multiplying a negative by a negative. So we can say negative x is greater than 0, which is greater than x. So therefore, by transitivity, this inequality holds. And therefore, we have proved this first property of absolute values. And we can call this property 1. Now I want to prove the following. This is the idea that the absolute value of x is equal to the absolute value of negative x. So we can write that as the following. Absolute value of x is equal to the absolute value of negative x. Now some of you might look at this and say that this is obvious, but it's still important to prove it using our definition of the absolute value. First, there's the trivial case where x is equal to 0. If x equals 0, negative x is also equal to 0, and the absolute value of 0 is 0, so therefore these are equal. From there, let's look at our two main cases. The first case being where x is positive. So case 1, we can say x is greater than 0. So if x is greater than 0, therefore absolute value of x is equal to x. So we take our argument here, it's positive, so it's equal to the same thing. So we have x. Then now negative x is less than 0, right? As I showed earlier, when you multiply these by negative 1, we can see that negative x is negative. So, because negative x is less than 0, to find the absolute value of negative x, right, we find the negative version of that. So we multiply this by negative 1, and we get negative x. So when you multiply a negative by a negative, then you get a positive number. So we get x is equal to x. So check, we've done that case. Now case 2. Case 2 is the case where x is negative. So x is less than 0. And therefore, just to be sure, negative x is greater than 0. So if x is less than 0, then the absolute value of x is equal to negative x. So we have our negative x. And negative x is positive, meaning that the absolute value of negative x is equal to negative x. The argument inside the absolute value stays the same. So we have negative x is equal to negative x. Therefore, in both cases, this property holds. So we can safely say that the absolute value of x is equal to the absolute value of negative x. And we can call that property 2. Now the third property involves products. So let's say I have the absolute value of a product. Let's say x times y. Now there's a property in which we can kind of separate this out and say that the absolute value of x times y is equal to the absolute value of x times the absolute value of y. And we can use this definition to prove this property. So let's look at case 1. And case 1 is that x or y is equal to 0. Now the 0 property tells us that if you multiply anything by 0, we will get 0. So therefore 0 is equal to 0, and we can kind of check that off. And this is a more trivial case. The next cases will be more complicated. Now, our second case will be that x and y, or y and x, are greater than 0. So y is positive, x is positive. Now what does this mean? Well, first of all, x times y is positive. So the absolute value of a positive number is just that number itself. So we have x times y. And if x is positive, absolute value of x is x. If y is positive, absolute value of y is y. So therefore, if they're both positive, this holds. Now, what if one of them is negative? For example, what if x was positive, but y was negative? And this is case 3. So if x is positive and y is negative, then x times y is a negative number, meaning that the absolute value of a negative number is the negative times that. So absolute value of x times y in this case is negative of that. So we have negative xy. Now, absolute value of x is x, and absolute value of y is negative y because y is negative. So we have x times negative y. And we can say these are equal to each other, right, because of the commutative property of multiplication. We have a negative 1 times an x times a y, and we have an x times a negative 1 times a y. So therefore, this third case is true. And this brings us to our last case. Case 4, in which x is negative and y is negative. So let's take a look. If x is negative and y is negative, x times y is actually a positive number because a negative times a negative is a positive. So the absolute value of x times y is just x times y. And on the right side, absolute value of x is x, or absolute value of x is negative x because x is negative. Absolute value of y is negative y because y is negative. So we have negative x times negative y. And again, by the commutative property of multiplication, we can switch around the negatives and they cancel each other out. Therefore, this last case is true. So therefore, in all cases, this property is true. So we can box that off, and we can call this property 3. So to summarize, there are 3 main properties of absolute values that we proved. So let's write these statements. So first of all, for all real numbers, x and y, so for all x and y in the real numbers, there are 3 properties. 1 is that the absolute value of a number is either greater than or equal to that number itself. 2, that the absolute value of a number is equal to the absolute value of negative of that number. So if you multiply the argument by -1, the output stays the same. And the third is that if you have a product inside your absolute value, that you can break up that product. So absolute value of x times y is the same thing as the absolute value of x times the absolute value of that y. And now hopefully because of this video, not only do you understand why these are true, but you can prove why these properties are true. Thank you very much for watching.